We're going to start by talking about translations. Remember, to translate something means to just move it around without changing the shape or twisting or anything. And we're going to start by talking about vertical translations, which affect the y-coordinate. When we want to translate a point upward by c units, we add c to the y-coordinate. So in this graph, we get h by translating f 3 units upward. That means we took every y-coordinate in f and we added 3 to it. To translate downward, we subtract whatever distance from the y-coordinate. So k is the result of translating f downward by 2 units. So that means every point on the graph of f, we subtracted 2 from its y-coordinate. Right? And you can see that the graph of h is the same shape as the graph of f, just moved up by 3. The graph of k is the same shape as the graph of f, just moved down by 2. To see how this is reflected in the formulas for these functions, let's just take a look at some key points on these graphs. So we'll start with f itself. On the graph of f, we see these 4 key points. And we could choose other points to look at as well, but those are the ones that really jump out at us and draw our attention. So those are the ones we're going to look at. So we have a point -4, +1. That means f of -4 equals +1. Because that's what it means for this to be the graph of that function, right? The x-coordinate is the input, the y-coordinate is the output. Here we have a point -1, 3, so f of -1 is 3. Here we have a point +3, -3, so f of +3 is -3. And here we have a point 6, -1, so f of 6 is -1. To see what's happened to h, we'll look at each of these points on the graph of f and find the corresponding point on the graph of h. So f of -4 is 1. Move that point upward by 3 units, and we get -4, 4. So h of -4 is 4. The point -1, 3 on the graph of f, move that upward by 3 units, and we get the point -1, 6. So h of -1 is 6. The point 3, -3 on the graph of f, move that up by 3 units, and we get the point 3, 0 on the graph of h. So h of 3 is 0. And then the point 6, -1 on the graph of f, move that up by 3 units, and we get the point 6, 2 on the graph of h. h of 6 is 2. So what we see here is that the inputs are the same, but the outputs are 3 higher. So to find h of x, if I want to find h of -4, for example, that's f of -4 plus 3. In general, h of x is what we get if we take f of x and then add 3 to it. Yeah, that's pretty easy. Let's look at k now and see what happens. We're going to do the same thing. Start with a point on the graph of f, and then look at the corresponding point on the graph of k. So -4, 1 on the graph of f. Move that down by 2 and we get -4, -1 on the graph of k. K of -4 is -1. -1, 3 on the graph of f. Move that down by 2 and we get -1, 1 on the graph of k. K of -1 is 1. 3, -3 on the graph of f. Move that down by 2 and we get 3, -5 on the graph of k. 6, -1 on the graph of f. Move that down by 2 and we get 6, -3 on the graph of k. K of 6 is -3. So our inputs are the same, and our outputs are 2 lower. So, for example, if I want to take k of -4, that's f of -4 minus 2. Right? We just take the output of f and subtract 2 from it. K of x is f of x minus 2. Okay, so to translate upward by 3, we add 3 outside the function. To translate downward by 2, we subtract 2 outside the function. So this is a pretty easy pattern. If we add a number outside the function, that means we've translated upward by that many units. If we subtract a number outside the function, we've translated downward by that many units. The direction of the translation is the same as the sign of the number. Positive is upward, negative is downward.